Hello dear children, welcome to maths class. Today I am here to discuss the lesson Arithmetic Sequence, just the first chapter of class 10 mathematics. And today we are discussing the first exercise, third question. Question is, write down the sequence of natural numbers leaving remainder 1 on division by 3 and the sequence of natural numbers leaving remainder 2 on division by 3. So we need to write two sequences, and the first sequence is a set of numbers that leaving remainder 1 on division by 3. Then which is the first natural number which leaves a remainder 1 on division by 3? Which is our first natural number? Yes, our first natural number is 1. Okay, and if we divide 1 by 3, what is the answer? See, if we divide 1 by 3, in 1, 3, how many times 3 in 1? 0 times, right? 0 times. So 0 into 3 is equal to 0. Then 1 minus 0 is equal to 1. So 1 is the remainder. That is, if we divide 1 by 3, we get a remainder 1. Okay, so the first number in our sequence is 1. Okay, then what about the second number? We know that, yes, 1 plus 3. 1 plus 3, which is that number? 4. Okay, 4 is the next number. And if we divide 4 by 3, what is the answer? In 4, 3 is 1 time, right? That is 1 into 3 is equal to 3. Then 4 minus 3 is equal to 1. Okay, that means if we divide 4 by 3, we get a remainder 1. Okay, so the next number of our sequence is 4. Then can you tell the next number on this sequence? Yes, 1 plus 3 is 4. Okay, then 4 plus 3, 7 is the next number. Then 7 plus 3, 10 is the next number. Then 10 plus 3, 13 is the next number. So this is our sequence, and the speciality of this sequence is if we divide the terms of this sequence by 3, we get a remainder 1. Okay, so this is the sequence of numbers which leaving remainder 1 on division by 3. Our next question, and or the second part of that question is, we need to find out a sequence which leaves a remainder 2 on division by 3. Okay, so we need remainder 2 on division by 3. Okay, we know that if we divide the first natural number 1 by 3, we get the remainder. What is the remainder? 0 into 3 is equal to 0. 1 is the remainder. So 1 is not there in that sequence. Then after 1, which is the next natural number? Yes, 2 is the next natural number. And if we divide 2 by 3, what we get? Yes, in 2, 3, how many times, how many 3's are there in 2? Yes, 0 times, right? 0 into 3 is equal to 0. Then what is the remainder? Yes, 2 is the remainder. So 2 divided by 3 is equal to, answer is 0 and the remainder was 2. Okay, quotient is 0 and remainder is 2. So the first number in our sequence is 2. Then what will be the next number in that sequence? Yes, if we consider the sequence 1, 4, 7, 10, etc. What is the difference between each terms of the sequence? See, 1 plus 3 is equal to 4, 4 plus 3 is equal to 7, like that. Okay, here also we divide the very same 3. So how do we find out the next term of this sequence? See, first number is 2. And the second number of this sequence is, yes, 2 plus 3. What is that? 2 plus 3 is equal to 5. Okay. Then what is the next number? Next number 8. Then next number 8 plus 3, 11. All these numbers leaving a remainder 1, 2 on division by 3. Okay. So this is our second sequence. Now the fourth question. Write down the sequence of natural numbers ending in 1 or 6 and describe it in 2 other ways. Okay, so we need to write a sequence of natural numbers that ending in 1. Okay, which is the first natural number that is ending in 1? Yes, first natural number itself is ending in 1, right? 1 is ending in 1. So first number is 1. And next 1 or 6. So the next number is, yes, 6 is the next number. Then which is the next number that is ending either in 1 or in 6? Yes, 11. Right? 11 is ending in 1. Then next is, yes, 16. Then next is 21. Then 26, and it is continuing like that. Okay, so this is our sequence 1, 6, 11, 16, 21, 26, etc. So we need to describe this sequence in 2 ways. Yes, first way. What is the first way? The first term of the sequence is 1 and the next term is 6. Then what is the difference between 1 and 6? Yes, we know that 1 plus 5 is 6, right? 1 plus 5 is 6. And the next term is 11. What is the difference between 6 and 11? Yes, 6 plus 5 is equal to 11. Okay, then the next sequence, yes, 11 plus 5 is equal to 16. Then 16 plus 5 is equal to 21. Yes, so the first way of describing this sequence is the sequence of natural numbers starting from 1 and 5 added continuously. Okay, sequence of natural numbers starting from 1 and added 5 continuously, we get the sequence. Okay, then how do we describe this sequence in other way? See, if we divide the first term of this sequence as 1. Okay, so if we divide this 1 by 5, what will be the remainder? Yes, in 5 is 0 times, so 0 into 5 is equal to 0, so 1 minus 0 is equal to 1, so the first number is 1, so leaving the remainder 1. Then what about 6? 6 divided by 5. What is 6 divided by 5? 1 into 5 is equal to 5. 6 minus 5 is equal to 1. Right? Then 11 divided by 5. Then in 11, 5 is 2 times. 2 5s are 10. 11 minus 10 is equal to 1. So what is special about these numbers? Yes, if we divide each number of this sequence by 5, we get a remainder 1. Right? So second way of describing this sequence is the numbers in this sequence leaving a remainder 1 on division by 5. Okay? The way of describing the second way of describing this sequence is the sequence leaves a remainder, leaving remainder 1 on division by 5. Okay, so this is the two way of describing the very same sequence 1, 6, 11, 16, 21, 26, etc. Okay, first way is sequence of natural numbers starting from 1 and added 5 continuously, and second way leaving remainder 1 on division by 5. Okay, these type of questions were discussed in 7th standard. Do you remember? Okay, and in this exercise, fifth question is a homework for you. So fifth question is a homework. Now we are coming to the second session of this chapter. Second section is about the relation between the position and the terms of a sequence. Okay, relation between the position and terms of a sequence. So the relation between terms and position of a sequence. For example, I am here to take a example or a sequence 4, 8, 12, etc. This one is a sequence. Okay, what is special about this sequence? Yes, starting from 4 and added 4 continuously we get the sequence, right? Then which is the next term of the sequence? First term is 4. Yes, first term is 4. Second term is 8. Third term 12. Then what about the fourth term of this sequence? Fourth term of the sequence, yes, 12 plus 4, that is equal to 16. Then what about the fifth term of the sequence? Without adding, can you say the next number of this sequence? To find out a relation between the position and the terms of this sequence. Okay, I am going to find out a relation between the position. Position means first is the position, second is the position, third is the position, fourth is the position, etc. are the positions. And the terms are 4, 8, 12, 16, etc. Okay, then what is the relation between the position and the first term? First term and the first position. Okay, that is, see, 4 and first position. 1 is the first position, means 1 is the number. Position, the number representing the position is 1 and the term is 4. Then what is the relation between 1 and 4? We know that 1 into 4 is 4. Right? 1 into 4 is equal to 4. Then what about the next number? Next number is 8. And what about its position? Its position is 2. Then what is the relation between 2 and 8? Yes, 2 into 4 is 8. Okay, next number is 12. 12 is 3 into 4. Right? That is third. Third is the position. Number is 12. So 3 into 4 is 12. Then next is 16, that is 4 into 4 is equal to 16. So what is the relation between term and position? Yes, position into 4 is the term. Okay, 4 into position. 4 into position gives the term. Okay, then can you tell the term in the 10th position? Which is the number in the 10th position of this sequence? Yes, 4 into position. 10th means 10 is the position. So 4 into 10 is equal to 40 is the number in the 10th position. What about the number in the 12th position? The number in the 12th position is, yes, 4 into 12. What is that? 48. Okay. And how do we write algebra of the sequence? Algebra. That means we need an equation for this sequence. We need an equation representing this sequence. And if n is the position of the number, the n is the position of the number, then the equation on this sequence is, yes, 4 into n. Okay, where n is equal to 1, 2, 3, etc. Okay, that is the equation of, or the general form of this sequence is 4 into n. 4 into n or 4n. Okay, 4n is the algebraic form or general form of this sequence, where this n is the position of the terms. Okay, That is first position, second position, third position, etc. If we need the first number, we just write 4 into 1. If we need the second term, we just write 4 into 2, 8. Then if we need the third term, 4 into 3, 12. Then if we need the 50th term, we just find out 4 into 50, that is equal to 200. Okay. So this is how we find out the relation between the position and terms of a sequence. Okay. And in the second exercise, we have some questions, and we are going to find out the algebraic expression of each sequences in that question. Okay, first question. Write the algebraic expression for each of the sequences below. The first question is sequence of odd numbers. Okay, first we are going to write the algebra of sequence of odd numbers. How do we write the sequence of odd numbers? What is the sequence of odd numbers? Yes, first number is 1, then 3, 5, 7, 9, etc. are odd numbers. This is the sequence of odd numbers. Now we are going to write the algebra of this sequence. That means we are finding out the relation between its position and term. Okay. So this is the first position, this one is the second position, third position, fourth position, fifth position, etc. Then, what is the relation between the first position and first term? Okay, relation between 1 and 1. 1 and 1. We can't find any relation, right? Then, what about the relation between 2 and 3? We know that 2 plus 1 is 3, but that is not the relation. Here 1 plus 1 is equal to 2, but here the number is not 2. Algebra means we can describe all the terms of the sequence using that algebra. Okay, so term plus 1 is, position plus 1 is not the term. Okay, then what is the relation between the position and term of the sequence? See, here the position is 3 and the term is 5. Here the position is 4, term is 7. What about the double of 1? What is the double of 1? That is, double of 1 is 2 into 1. Okay, what is 2 into 1? 2 into 1 is 2. Okay, minus 1. What is that? 2 into 1 minus 1 is equal to 1. Okay, that means the double of the position minus 1 is equal to the term. Okay, then if we consider the second term, is it satisfying this condition? Let us check. That is, the position is 2. Okay, position is 2. And double of 2 is 2 into 2. Okay, 2 into 2 minus 1. 2 into 2 is 4. 4 minus 1 is equal to 3. Yes, the second term is 3. That is equal to double of the position minus 1. First number is double of the first position minus 1. Then, what about the third term? Third is the position. So, double of the double of third is 6. 6 minus 1 is equal to 5. Okay. Then, what about double of the fourth position? Fourth position number is 7. Okay. What is double of 4? Double of 4 is 8. 8 minus 1 is equal to 7. So, that is the relation between the terms and the position of this sequence. So, how do we write the algebra? Algebra means we need a variable, right? If we take n as the variable, or we need to find out the term in the nth position. The first number is, yes, double of first minus 1. The second term is double of second minus 1. Third term is double of third minus 1. Fourth term is double of 4 minus 1. Okay, then what about the nth term or the algebra? Yes, double of n minus 1. Okay, double of n minus 1 is the algebra of this sequence. Or simply we can write 2n minus 1. This is the general form of a odd number. Okay, this is the general form of a odd number. You have studied this from 7th standard and 8th standard also. Okay, general form of an odd number is 2n minus 1 where n is equal to 1, 2, 3 etc. And can take the values 1, 2, 3 etc. So the algebra of the sequence of odd numbers is equal to 2n minus 1. Okay.
Start.
Okay, now the second sub-question of the first question of second exercise. That is sequence of natural numbers which leave remainder 1 on division by 3. Okay, we know that sequence. For natural numbers which leaves remainder 1 on division by 3. From this class itself we know the sequence. Which is that sequence? Yes, 1, 4, 7, 10, 13 etc. is the sequence. Okay, what is special about this sequence? In this sequence all the numbers leaving a remainder 1 on division by 3. Now we are going to write the algebra of this sequence. Okay, algebra of this sequence. So 1, 4, 7, 10, 13 etc. are the numbers. Right? Now we are going to find out the position and find out the relation between the position and terms of this sequence. Okay, this is the first position, this is second position, third position, fourth position, fifth position, etc. Then, how do we find out the relation? See, this number is, if we see on division by 3, we have a closed division by 3. So, is there any relation between the multiples of 3 and these numbers? See, the first number 1. Okay, that is 3 into 1 minus 2 is equal to 1. Okay, that is here we dividing each number by 3. Okay, so we are going to find out a relation between the multiples of 3 and the position and the terms. Okay, so 3 into 1. 3 into 1 is the first multiple of 3. Okay, 3 minus 2 is equal to 1. That is the relation between the first term and the first position. Then, what about the second term and second position? Okay, which is the second multiple of 2? That is 3 into 2 minus 2. 3 into 2 is equal to 6. 6 minus 2 is equal to 4. Okay, that is the second number. Okay, so 3 into 1, 3 into position minus 2 is equal to first term. 3 into second position minus 2 is equal to second term. Then what about the third term? Yes, 3 into third position minus 2 is equal to the third number. What is that? 3 into 3 is equal to 9 minus 2, 7. Yes, 7 is the third term. Okay, then what about the fourth term of this sequence? Yes, fourth term, that is 3 into 4 minus 2. That is equal to 3 into 4 is equal to 12 minus 2 is equal to 10. Then what about the 10th term of this sequence? The 10th term of this sequence is equal to 3 into 10 minus 2. 3 into 10 is equal to 28. 28 minus 3 into 10 is equal to 30. 30 minus 2 is equal to 28. Then how do we write the relation between the term and the position? So all the terms of this sequence and the position are related this way. That is 3 into position minus 2 is equal to the term. Okay, term is equal to 3 into, this is the position. 3 into position minus 2 is equal to term. Or we can write the algebra of this sequence as 3n minus 2. Okay, so this is the algebra of the sequence. See children, if you have any doubt on this section, you can call me any time. Okay, and watch this video more and more times and learn this section. Okay children, so this much only for today children. Thank you.